and welcome to this episode of Night Sky News for September 2025 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this episode, we're chatting about the big news that the Perseverance rover has found intriguing evidence for possible past life on Mars. Plus, JWST's look at the atmosphere of TRAPPIST-1e, an Earth-like exoplanet that we've all been impatiently waiting for, and an update on 3I Atlas, the interstellar comet that's been visiting our solar system. There's chapter markers down here if you want to skip ahead to any specific news story, plus any research papers I mention are all going to be linked in the video description down below, free to read. So without any further ado, let's kick things off and start by looking up. Alright, we are now officially into astronomical autumn here in the Northern Hemisphere, or spring if you're in the Southern Hemisphere, after the equinox a few days ago, which means everybody around the world right now has around about 12 hours of nighttime to enjoy the night sky. So, what should we look out for? Well, Saturn is especially bright right now because on the equinox it reached what's known as opposition, where the Sun, Earth and Saturn all make one straight line in their orbits, putting Saturn in the exact opposite part of the sky from the Sun, hence the name opposition. This means it's also fully lit by the Sun from our perspective here on Earth, and also the closest Saturn gets to Earth as well, meaning it is the brightest that it can get in our night sky in the weeks around opposition. So it'll be up all night and visible wherever you are in the world. So if you're looking for it before midnight, look towards the east. Around midnight, look south or north if you're in the southern hemisphere. And if you're looking after midnight, you should look towards the west. Now, Saturn has got a slight yellowish tint to it, and it won't twinkle like stars. It'll look much more like a solid light. So that should hopefully help you to pick it out from the background stars around it. But if you're still not sure that what you're looking at is actually Saturn, handily the moon will swing past it on the 5th and 6th of October. That's going to act as a very nice bright signpost of where to look. Now, once you've spotted it, you might want to break out your binoculars or your telescope to have another good look at Saturn, but just be aware you can't really see the rings right now because they're pretty edge on from our perspective. They're very thin. There's not much to see. We have to be a little bit more patient, wait for Saturn to move along its orbit so that the rings tilt back round to us around about the start of 2026. Now, Neptune is also at opposition at the same time as Saturn, so they are very close together on the sky. You can't see Neptune with just your eye though because it's too far away, it is too faint. So you will need a telescope for this one, but if you're breaking it out for Saturn, you might as well see if you can find Neptune while you're at it. Then on the 7th of October, the moon will then be full. It'll be very bright because it also classes as a supermoon. So this occurs when we get a full moon, when the moon is at the position in its slightly oval shaped orbit around Earth, where it brings it actually slightly closer to Earth than normal, around about 40,000 kilometers closer. That means the full moon is technically larger and brighter in the sky, but these differences are very slight. So yes, it's 30% brighter than when it's a micro moon, when it's the furthest away it gets from Earth in its orbit, and 14% bigger. But because you don't have a normal moon or a micro moon directly there to compare the supermoon to, your eyes can't really pick out any difference. If the moon does look bigger to you than normal that night, I'm guessing because it'll be low down in the sky still and you're experiencing what's known as the moon illusion, where you're comparing it to nearby objects like buildings and trees that you do know the size of, and it looks, giant in comparison to those, but actually it is the same size as it appears when it's directly above you as well. It's just the illusion because you have the comparison. I think the only people that really ever notice a supermoon are people who really truly live away from any city lights and have truly dark skies, and you can get those really crisp, clear moon shadows from a full moon. Now, the supermoon actually sadly interferes with one of the 2 meteor showers that we've got in October. So the first one being the Draconids that peaks on the 7th of October, and then the Orionids that peak on the 21st of October. Now, both the Draconids and the Orionids are caused by Earth passing into a debris trail left behind by a comet. And in the Orionids case, they're actually caused by the famous Halley's Comet. Now, you might see a lot of hype in the media in the next couple of weeks about these meteor showers, but I just want to, manage expectations a little bit for what you can actually see. First of all, you really need a dark sky for meteor showers. If you're in the center of a city with really bright lights, I wouldn't even try bothering to see any of the meteors from the Draconids or the Orionids. The big thing also is the moon. With it being so bright, it can actually cause a very bright glow across the whole sky, which can wash out all but the brightest of meteors. So for the Draconids, the moon will not only be a full moon, but also a supermoon and a lot brighter than normal, meaning the sky is going to be a lot brighter during the peak of the Draconids as well. Combine that with the fact that it's not the most active of meteor showers. There's really only, sort of like 10 meteors an hour. That includes the really faint ones as well. So that's only a meteor every 6 minutes or so. I'd say it's just not worth trying to see any of the Draconids this year. But the Orionids, which peak 2 weeks later on the 21st of October, there'll actually be a new moon that night, meaning the skies will be beautifully dark all night, making it an excellent year to try and spot the 20 meteors or so an hour that the debris trail from Halley's comet brings. So some patience required for this one because, 20 meteors an hour means roughly a meteor every 3 minutes or so. And that again includes the faintest ones that you couldn't see in the center of a city, for example, but in the darkest skies you could. And if you want to try and spot this, you should really look anywhere in the sky except for the constellation of Orion, which is where all the meteors are going to appear to be shooting away from. So wrap up warm, lay as flat as you can just to save your neck, and look directly up around about midnight, and you should have a good chance of spotting some Orionids. Now, as we get into mid-October, one of the things to be thankful for here in the Northern Hemisphere is that because the sun is rising later and later each morning, you don't have to get up at silly o'clock to enjoy some of the, before sunrise night sky views. Like Jupiter and Venus that are visible right now in the morning before sunrise. These are two of the brightest objects in the night sky, Venus being the brightest, closest to the horizon, and then Jupiter higher in the sky, not as bright as Venus, but much brighter than the surrounding stars, which again should help you to pick it out if you are looking in that direction of the sunrise. Venus and Jupiter should be the only things left visible, like right before the sun rises. All the other stars should slowly disappear as you get that light from dawn approaching. But again, if you're not sure what you're looking for, we've got that signpost of a half moon, which will swing past Jupiter on the morning of the 14th of October before it continues to wane and joins Venus as my beloved toenail moon on the morning of the 19th of October. So look towards the sunrise for that one, around about half an hour or so before the sun comes up, which at this time of the year here in the UK, it's like 6:30, 7 o'clock, right? That's like normal get-up time for most people for like work and for school. You don't have to get up at silly o'clock to enjoy this, and you get to also sort of enjoy this beautiful sight as you like bask in the stillness, right, of an early morning and feel weirdly productive that early in the morning when all you've really done is pick out the beauty of Venus and Jupiter on the sky. Now, if you're struggling to visualize how the movement of the planets and the moon in their orbits actually translates to then, okay, what do we see in the night sky? That's totally understandable, right? It's a big 3D thing with lots of moving parts and it's hard to keep in your head. But if that is you, I have something that might help. So before we get to space news, let me tell you about the sponsor of today's video, Brilliant. Brilliant helps you get smarter every day with thousands of interactive lessons in maths, science, programming, data analysis, and AI. Brilliant is a learning app designed to be uniquely effective. So each lesson is filled with hands-on problem solving that lets you play around with concepts, a method that's been proven to be 6 times more effective than just passively watching lecture videos. And that's because Brilliant's first principles approach helps you build understanding from the ground up. And it's this perfect mix of engaging problems, competitive features, and daily encouragement that keeps you motivated and on track. So I absolutely love their scientific thinking course because it introduces you to key scientific principles and theories, from simple machines like gears and pulleys to Einstein's theory of special relativity. It'll help you build your natural intuition for science while also gaining a deeper knowledge of scientific principles. And I think it's perfect for learners of every level. So to try everything that Brilliant has to offer, visit brilliant.org/Dr. Becky, or you can click on the link in the description below, and you'll also get 20% off an annual premium subscription, which gives you unlimited daily access to Brilliant. So a big thanks to Brilliant for sponsoring this video. And now let's come back down to earth and chat about what's been happening in space news in the past month. All right, let's start by chatting about JWST's highly anticipated look at the atmosphere of the exoplanet TRAPPIST-1 An Earth-sized planet in the habitable zone around its star, so the region where the amount of light that a planet is getting from its star, would mean that that planet would be not too hot and not too cold for life, at least as we know it here on Earth, to exist there. So for those of you who caught my video from 2 weeks ago on the atmosphere of TRAPPIST-1d, another planet in the system, will know why there is so much hype around the planets in the TRAPPIST system, not least because there are so many planets known in this system, but also because they're all roughly Earth-sized, and because previous observations with the Hubble Space Telescope couldn't rule out the possibility that these planets have no atmosphere at all. So there's been a lot of excitement around these planets. But the type of star that they're orbiting, that's at the center of this 7-planet system, is what's known as a red dwarf star, which are much smaller and cooler than the sun, hence why the planets in this system also orbit so close in, but are still in the habitable zone. And recent research has cast a lot of doubt about whether planets orbiting red dwarf stars will even be habitable at all, because they throw off a lot of deadly radiation, which would be damaging to any burgeoning or existing life on that planet, but also that radiation can strip away any atmosphere around the planets, similar to what we think happened to Mars in our own solar system. So there's lots of questions around these planets in the TRAPPIST system, especially the ones in the habitable zone, and the hopes has always been that JWST can reveal what their atmospheres are made of. What we do is we wait for the planet to pass in front of its star and block a little bit of the star's light. This is what's known as a transit. It's actually how we even detect a lot of planets are there in the first place. And if you take the light from before the transit of just the starlight, and then the light from during the transit, and take one from the other, you'll be left with just the light that's passed through the planet's atmosphere, so that you can see what effect, if any, the planet's atmosphere had on the light. So if the atmosphere had molecules like water or carbon dioxide in it, they would steal away certain colours or wavelengths of light and just leave this little fingerprint to show that they were there. We've already had results from JWST for what the atmospheres are like of the inner planets in this system, TRAPPIST-1b and TRAPPIST-1c, close into their star, and there wasn't much signs of an atmosphere on either of those. Then earlier this month, we heard that TRAPPIST-1d, right on the inner edge of the habitable zone, most likely had a very thin atmosphere, and there was no evidence for any of the molecules that we typically look for in terms of habitability, at least for life as we know it anyway. So what about TRAPPIST-1e, right in the middle of the habitable zone, receiving a similar amount of light from its star as the Earth does from the sun? Could this have an atmosphere of the right composition and be thick enough to support the existence of liquid water on the surface of TRAPPIST-1e? Well, we finally got our first insights on this from these 2 research papers that were published this month by Espinosa and collaborators and Glidden and collaborators. They used JWST to observe 4 transits of TRAPPIST-1e and extract the fingerprints left on the starlight by the atmosphere. And it was by combining the data from those 4 individual transits, whilst also removing any contamination from just like a variable starlight between the 4 different transits, to leave behind that spread of light where you've got this fingerprint of the atmosphere left on it. So here on the x-axis, we've got wavelength or color of light. And then on the y-axis, we've got transit depth, or how much light was stolen away. The higher the number there, the more absorption at that wavelength, so the more of a certain molecule that likes to absorb that wavelength of light away, the more of that molecule there is in the atmosphere. That is the reverse of the like little animation that I just showed, which actually showed like if there was more of that molecule, you were missing more of the light. So it's just sort of flipped here. Basically, if you see a bump in the data here, it means there's probably a molecule present in the atmosphere. So you can see that really clearly in the grey line, right? That shows what an Earth-like atmosphere would look like under the same conditions with JWST. And you can see like a bump from carbon dioxide really easily there, for example. But the data from TRAPPIST-1e's atmosphere is not as clear though. That's what's shown by the black dots here, with the uncertainties on those measurements shown by the lines either side of those black dots. And then first of all, what they do here is fit a flat line to the data, i.e. they fit like if there was no atmosphere, how good of a fit would that be? That's what's shown by the orange line, whereas then the best fit model of an actual atmosphere of TRAPPIST-1e is shown by the blue line. And you can probably tell just by looking at this that it's hard to tell which one's a better fit here, right? The data is very messy. If there is something there, the signal is very weak with just these 4 transits that have been observed. But with this data, what Espinosa and collaborators could say is that a hydrogen-dominated atmosphere, like, the gas giants have Jupiter and Saturn, that is very, very unlikely given this data we have for TRAPPIST-1e. So Glidden and collaborators looked at this further in the context of what's known as a secondary atmosphere. So not a primary atmosphere, not the first one that was formed when the whole star-planet system originally formed, but the secondary atmosphere, what's left behind after the planet's been bombarded with radiation by a red dwarf star, or perhaps maybe it's had it completely stripped away and then an atmosphere has reformed thanks to maybe volcanic activity on the surface of the planet. So Glidden and collaborators consider lots of different scenarios, including atmospheres similar to Mars, Venus, Earth, and Saturn's moon Titan, where you've got a 95% nitrogen atmosphere. And they did manage to rule out carbon dioxide dominated atmospheres like Venus and Mars, and again ruled out the hydrogen dominated atmospheres. What they couldn't rule out, though, with this data was a nitrogen-rich atmosphere that also contained carbon dioxide and methane, similar to Earth, or in the extreme, Titan. But they also couldn't rule out a bare rock scenario, i.e. a planet with no atmosphere either. Both scenarios fit the data, but don't fully explain every bump and feature seen in that fingerprint left on the light. So of all the TRAPPIST-1 planets that JWST has looked at so far, I think these are the most promising results for the planet TRAPPIST-1e. It could be that it has a very similar atmosphere to Earth, 70% nitrogen like we have here on Earth. And that's great if we want to try and find an atmosphere that could potentially host life, at least as we know it here on Earth. But we don't know that for sure yet. The data, the signal just isn't strong enough there. So I think the next steps will be to get more transits of TRAPPIST-1e in front of its star to just add into the data here and hopefully get a stronger signal. All right, sticking with this theme of searching for life out there in the universe, we have got to talk about this research paper from Hurwitz and collaborators, who have claimed to have found organic material which could be a sign that life once existed on Mars. This is all thanks to the Perseverance rover, little Percy, that is still roving and exploring Jezero crater on Mars, thought to be a dried up river delta where water once flowed on early Mars billions of years ago before its atmosphere was lost to space because of being bombarded by radiation from the sun, and then all the water boiled off. So because of this, Jezero crater is a really interesting region to explore, and Perseverance has been taking core rock samples of interesting looking rocks for a while now, including the Bright Angel rock formation region that's been studied here, specifically a rock that was nicknamed Chayava Falls by the team. And hopefully you can see in these images how the rock has these little leopardy grey spots that stand out from the reddish background rock of Mars. And it was those leopard spots that originally intrigued the Perseverance team because they hadn't seen anything like that on Mars before. So utilising all of the lab equipment on board the Perseverance rover, they first scanned the rock to work out what it was made of, and that gave them this plot. In particular, they were looking for one feature, one fingerprint that says this rock contains lots of carbon. Specifically, the carbon-containing molecules that tend to be used to power life's processes. In particular, when they look more closely at the composition of the rocks found, 2 molecules in particular stood out. Vivianite, an iron phosphate, and greigite, an iron sulfide. I have no idea if I've pronounced either of those words correctly, so any geologists or chemists watching can correct me down in the comments if they were wrong, but these 2 molecules tend to be associated with life here on Earth, specifically microbial life where there's been decay, and it's very common to find them in sedimentary rocks where life has been present. And in fact, this rock sample that Perseverance has taken is in fact sedimentary, meaning it had likely formed from grains of sand deposited over many, many years as water flowed over the surface. So these dark spots that Hurwitz and collaborators have found could be this sort of interface between past life on Mars and the rock around it. Sort of the boundary between where there's just chemistry occurring in the rock and biochemistry occurring. However, we cannot get ahead of ourselves just yet, because there are other ways to make both of these minerals that don't involve life at all. They just can form through normal chemical processes. But to do that, you either usually need very high temperatures or very high acidity. And Horowitz and collaborators couldn't find any evidence that the rock sample that Perseverance took had been put through any high temperatures or acidic conditions in the past. But that doesn't mean that there still isn't some as yet unknown to us chemistry that could be producing these two minerals here without the need for life. So that puts this result at level 3 on NASA's confidence of life detection scale that they put forward back in 2018. If you look, we haven't reached level 4 where we could rule out all non-biological sources for what's been found. To get a more definitive answer on this, we'd need to bring these rock samples back to Earth. The rover's limited lab equipment means we can do some tests on the rock samples in situ on Mars, but the plan for Perseverance rock samples was always to deposit them on the surface for a future mission to return to Earth for more intricate testing. But with the current US government's proposed cuts to NASA, that mission will be scrapped. So unfortunately, there's no plans to test this interesting sample any further because we've done everything that we can do in situ on Mars with Perseverance, which to me feels like a missed opportunity for science and a missed opportunity to maybe move one more step up that scale towards a definitive detection of life elsewhere in the solar system. Let's stick in the solar system now for our final update of this Night Sky News episode, because I've seen a few of you in the comments asking for updates on 3I Atlas, the interstellar comet visiting the solar system that was discovered back in July 2025. So this is an asteroidy comet-like object, so a lump of rock essentially, that instead of orbiting the sun like everything does in the solar system, it is instead just passing through. It formed as part of another planetary system around another star in our galaxy, and then because of all the interactions that take place between all of these objects, there's a lot of chaos, it got ejected from that star system and has been traveling through outer space, interstellar space, ever since, until it's happened upon the solar system. There's been 2 of these objects found in the past as well. The first, 1I, was dubbed Oumuamua, found in 2017, and the second, 2I, dubbed Borisov, was detected back in 2019. And we know these are interstellar objects thanks to their movement through the sky. So like with any new asteroid discovery, we track how their positions change on the sky over time, and from that can work out their orbit around the sun. But when we do that calculation for interstellar objects, we find that orbit never loops back around. Instead of being a circle or an oval, the orbit shape is what's known as a hyperbola. Basically, these interstellar objects, they come into the solar system, they loop around the sun, and then slingshot back out again, visiting us for just a very brief time. And spotting them depends on our limits to telescopes, how faint of an object they can see, but also just random chance as well. Just did an interstellar object happen to pass through the tiny region of interstellar space that is the solar system? So since 3I Atlas was spotted by the Atlas Survey Telescope in Chile in July, there have been many follow-up observations with different telescopes all around the world and in space as well, trying to find out more about this object. And when more was found out, research papers have been published. And side note, for those that missed it, a research paper was recently published saying, if this was an alien spacecraft, what could it do to reach Earth? And they did this as a pedagogical exercise, i.e. as a teaching moment, right? Saying, let's think of this hypothetical scenario and see if we could learn something. But of course, the internet, being the absolute bin fire that it is, took that and ran with it. So if you have seen anything online recently that claims that 3I Atlas is an alien spacecraft, know that this paper is where that came from, and I guess it's worth reiterating here again that we have absolutely zero evidence to support that idea. What we do have are observations of this comet's tail, so its halo of gases that escape from the comet as it heats up as it gets closer to the sun and changes as it gets ever closer. So we've seen this with the Hubble Space Telescope and the Gemini Telescope on Hawaii, and also VLT in Chile, but also with JWST as well. So this paper from Coordinate and collaborators caught my eye this month, who used JWST to observe 3I Atlas. A sentence in itself which is just incredible to say. Like, it's amazing they could even do this, because JWST was designed to have an absolutely tiny field of view to be able to drill down on incredibly faint, incredibly distant objects. So to actually get a comet moving at 200,000 kilometers an hour into that tiny field of view, you need to know the orbit of that thing so incredibly accurately to be able to do this. So hats off to the team that did this. Coordinate and collaborators report that they used JWST to take an image of the comet tail, but also they managed to break down the light from the comet into a spectrum, that spread of how much light of each wavelength they receive, to once again pick out the fingerprints left behind by certain molecules so that we can know what the comet is made of and what the gas outgassing from this comet is made of. And Coordinate and collaborators found the gas is mostly made of carbon dioxide, but also has some signatures of water and carbon monoxide in there as well, which is exactly the same kind of mix of gases that you'd expect for the tails of solar system comets as well, right? So you might think, oh, that's nothing new, that's not a big deal, but it is a big deal, because this is not a solar system comet. It wasn't made here. It was formed around another star in our galaxy, and yet it has the same mix of materials as a solar system comet does as well. Albeit one with a higher ratio of carbon dioxide versus water than we're used to for solar system comets, at least for those formed closer in towards the sun. It maybe is a bit more reminiscent of like a distant Oort cloud comet instead. So perhaps wherever it formed around its star, it did so at a very large distance away before being ejected out into interstellar space. So what's next for 3I Atlas? Well, it makes its closest approach to the sun very soon in late October 2025, passing just inside the orbit of Mars before it speeds back out of the solar system. And it's worth stating here, I think, that this is not a danger to Earth, this comet. It doesn't come close enough to us, and also it's moving so fast that we sadly don't even have enough time to send a mission to actually go and investigate it. But there are observations planned with the satellites in orbit around Mars. So ESA's Mars Express and the ExoMars Trace Gas Orbiter will both observe 3I Atlas as it passes just 30 million kilometers from Mars. For context, that is less than 10% of the Earth-Moon distance, so it's pretty close to Mars. But the cameras on board these satellites have been designed to look directly down to the Martian surface, which is relatively close by to them. So the comet's main body, that lump of rock, will only take up about a pixel on each of the detectors of these satellites, but the comet tail should take up a much larger amount of the detector, a much larger amount of the camera's field of view, and we should be able to use the instruments on board to once again test what the tail of the comet is made of. But the spacecraft that should have the best view of 3I Atlas is the JWST spacecraft, currently on its long journey to Jupiter. And so it's also going to turn all of its instruments to look at 3I Atlas when it gets a really good approach in November 2025, so we can see what more can we learn about this interstellar visitor before it leaves the solar system again for good. All right, that's it for Night Sky News for this month. As always, a very big thank you from me and mine for all of the well wishes for my health. We really appreciate those. I am recovering really well after surgery. My next step is that I will be starting chemotherapy very, very soon. That is not to treat any cancer as far as we can tell. All the tumour is out and there was no lymph node spread. This is all about reducing the risk of recurrence in the future because I am at a relatively young age to have gotten breast cancer. I've no idea how I'm going to react to the chemo drugs because it is so individual to every single person. It's incredibly hard to predict. But my aim is to continue at least making a Night Sky News video every single month because I love making videos for you all. It's something normal for me to do and routine for me to do. So I'm going to try and stick to that. But apart from those, there might not be as many videos as there usually are. There'll be some that we'll post that I'll have filmed before chemo. But apart from that, there's not going to be regular weekly videos from me now for the rest of the year. I will be trying cold capping to keep my hair, which is like a 50-50 chance. So everybody just keep your fingers crossed for my beautiful hair. Like I said last time, if there is anybody else out there that's going through the same thing right now or something similar, know that I am with you every single step of the way throughout this. And also know this does not define us in any way, shape or form. So until next time, everybody, all that's left for me to say is happy stargazing. Strong on us isn't strong enough. Planets that JWST has looked like Chayava Falls. Crap, I didn't look up how to pronounce that. Chayava Falls pronounce. Do we trust the Weather Network on Facebook to tell us how to pronounce this, or Astrophil? Oh my god, that's so loud. Chayava Falls. My door is still open so the cat can get in, but don't want her in at the minute because she distracts me. Greigite and iron sulfide. I haven't looked up how to pronounce those either. Vivianite and Greigite. It could be Vivianite. Vivianite. Greigite. No, absolutely not. I've never watched Only Murders in the Building. Is it good? I really don't think it's Greigite. If there are any chemists or geologists in the building, the gas outgassing. To say, sorry, before I did that, I pressed my thumb probably a little bit too hard into my temple and that really hurt. Don't press into your temple, folks. I've now remember a running joke that the fact that I'm known as Dr. Becky makes me sound like a medical doctor. Statements like that make you realise I am most definitely not.